we can use graph semantics in Fabric. So it's what you see here is Fabric, and I've now opened an artifact, a KQL query set, which is connected to a database, to an event house. And what this scenario is showing here is something that's called offensive security, also Bloodhound. And what I tried to show here is how, like, other queries, how other databases are using graph query language in order to express the problem that they're trying to solve, and how we can do that directly in Kusto or in Event House in Fabric Real-Time Intelligence. So what you see here is I'm creating a graph object with a let statement, which is just an expression. And something very cool happens here. I'm using an external table or a shortcut to OneLake. So the data is not actually running in the engine of Kusto. It's external and it's sitting on OneLake. So all your data estate in Fabric is supposed to be on OneLake, and you can query it using any engine that you like. And in this example, that engine is Event House. So this one is querying this adjacency list, the cybersecurity edges. And then it's creating a graph object during query time. It says, okay, I want to map source to destination, and it's connecting it with, it's enriching the nodes with information about the nodes sitting in a different folder on OneLake. And then it's doing it's implementing like two graph match operators, one for the user access and one for the group access. So what it's doing here is says, okay, I'm interested in users that can RDP into a computer. See, it's very easy to read. It's very easy to digest. You don't need to think about complicated joins. And the second one here in line number 19 is a user that is a member of a group that can RDP into a computer. So again, like very easy to understand. And when you run it, what happens is the event house is being created. So that's why the initial query takes a little bit longer. So we're creating a complete new database here. Then it's the engine is reaching out to the underlying storage, querying the data from that storage, creating the graph, and then processing the graph match operator. So all of that is happening in right now 7 seconds, which is very long, but you have to take into consideration that the entire event house was created. The graph was read from a storage like OneLake, and all of that happens instantaneously here. Now, this is a very interesting statement. It's a little bit more complex, so I'm not going too deep into it, but it's working on a scenario which is very interesting for IoT and industrial IoT. In IoT systems, let's think about a production line of a big manufacturer. All of them are measuring the data of sensors, so they collect sensor data. And think about this scenario as being a pump in a production line connected to a different asset or an asset, and that pump has a pressure sensor. So you would like ingest all of that pressure sensor data into something like real-time intelligence or event house, and then you would like to find anomalies. So there are out-of-the-box capabilities in event house to detect anomalies. And that's what you see here in this part. So we're getting all of this sensor data. We are creating a time series. From this time series, we are filling up values. Then we are finding anomalies, and then we are tagging assets that have anomalies. All of that is happening in this single statement. Now we are building the graph using this part. So we are interested in something that happened on a specific day. So we do something that's called the graph time travel. So we are creating the graph at exactly the point in time that is interesting for us. So we get the adjacency list or the ad or the assets and how they were connected and at a specific point in time. We get the nodes that were part of these assets at a specific point in time. And then we are creating a graph over here. Once we created a graph, we are using this statement to find out, hey, what is actually the impacted production line by those anomalies. So here we're finding all anomalies in the first part. And now we're doing something like a blast radius analysis. So to go back to the initial example, I start with a pump that has a pressure sensor, which has anomalies. And now you want to find out what happens if that pump explodes. Okay, so what is the blast radius of that asset having a malfunction? And in order to do that with other systems, you would need to have like a time series database, a graph database, some glue code which is connecting all of that together. And here you have everything in a single place. You get IntelliSense of KQL, which is very convenient. Yeah, so once you defined the pattern, you just say, okay, I'm interested in assets that have an anomaly. And at the end of the day, I would like to say that I'm interested in the lines or production lines. So I'm filtering down here, and then I'm projecting back the asset and the factory. And last but not least, I can calculate the impact using a summarize statement. So what you see here, it's a combination of time series database, including time series capabilities, graph capabilities, and just classic, I would say, like Kusto BI. So you're doing a group by a couple of dimensions, and you're executing it. Again, this will take some time because I probably waited too long until it ran. And what you see here is that everything is super fast, and you can use time series and graph in one statement. If you're interested in visualization, then you probably know like that actually most of our experiences are built for data engineers, but still, you know, we have a good some good visualizations in some of our tools. So this is a visualization of a social network, and the visualization is done in something that's called Kusto Explorer. It's a free tool. It's creating a 3D graph of users that have repositories. And what is also very important for a couple of like security scenarios, cybersecurity scenarios, is to understand like how a certain graph was developing over time. So all of that, what you've seen before, can also be visualized in a tool that is called Kusto Explorer, and we're also going to bring it to the web. But it's just a small example of how graph visualization could look like.